Now, your r squared value is a little bit better, okay? 0.6485, boy, this is a really crappy screen, you can hardly read that. 0.64 versus 0.63, it's a little bit better of a model. How many of you would prefer to use that logarithmic equation? No, me neither. I'd probably stick with that. If I did a polynomial, 0.65, that's a little better. If I did the power, 0.64. So none of these are really improving all that much. Let's go to our golf question here. So this gives us an r squared of 0.88. I can't see it. Move over here. Dang it. So I think this one might play two equations. Oh, here we'll compare these and the r squared. Oh, dang it. Okay, so we can kind of compare these a little bit. R squared's there. Okay, the exponential. Okay, so 8, 7, that's not really doing anything for us. 8, 8, polynomial. 8, 8, oh, these aren't really changing all that much. 8, 7. Okay, tell you what, here's what we're going to do. We're going to go to the non-correlation coefficient, okay? Well, this one already has it on here, okay? So just for fun, let's put in my linear, okay? What do you think? So this one here says y equals 31.6 miles per gallon. Doesn't matter how fast you go, you're going to get 31.6 miles per gallon. Is this a very good model? What percent of variation is explained by y equals 31.6? Nothing. It's a terrible model. Now, when you find your correlation coefficient and it comes up 0, you're going to say those aren't correlated. Is that true? Are those not correlated? It is not true. They're correlated, right? But they're correlated. Now, you can put logarithmic. That gives me 0.009. Is that a very good model? It's better than the last one, but it still sucks, right? The polynomial, ooh, look at that r squared value. Okay? 91.91. What do you think of that model? That's a really good model, right? So probably, now that equation isn't the funnest equation ever, okay? But there, and then we got power. What do you think of the power function? It's not a good model, okay? So in this case, you could do a polynomial order 2, or you could go 3. It's like, there, that doesn't really help you. 4, ooh, that's like perfect. Ooh, that's 100%. That's a really good model. Okay? So at any rate, I'm just kind of showing you this kind of so you can compare models and see which one's better. I'm not going to ask you to pick anything but linear, and I'm going to ask you based on linear. In this case, would you say those are correlated? Non-linearly. Okay? That's a terrible equation otherwise. All right. So, okay, I'm trying to decide if I want to finish up or I want to show you that movie that I was going to show you. Let me show you the movie. Okay?
I don't need to.
Oh, except for I can't remember my password.
That's fun.
It is a cool movie. Okay, tell you what, I'll think about this. I'll see if I can remember it during your quiz today. I'll show it to you in the class. Okay, so let's talk a little bit. I think it was, I don't see Nicole here today. Is she here? She asked a little bit last time about causation. Okay. So the question of causation. Okay, number one, a strong relationship does not necessarily mean a change in one causes a change in the other. Okay? 2, the relationship is often influenced by lurking variables. Number 3, the best evidence comes from randomized experiments. Now, one of the problems with that is you could say, well, we could do a regression equation. We could say, how long are you going to live based on how much you smoke? Okay? So if you cut your smoking, do you think that would help you live longer? Probably would. If you smoke more, is that going to make you live less? Probably would. Relationship is often influenced by lurking variables. People who smoke generally have other poor habits. Probably don't eat well. Okay? So diet could be a lurking variable. Best evidence comes from randomized experiments. How many of you want to volunteer to be in my smoking study? Okay? It would be really nice if you would. I would randomly pick some of you to smoke and some of you not to smoke. Okay? But that's not very ethical of me, is it? Okay? Especially since we know that. So that's the best evidence. Sometimes we can't do that though. 4, the observed relationship may be due to a direct cause. Okay, it could be that smoking really does cause cancer, and we seem like we've got enough evidence of that now. B, a common response. Or C, confounding. Okay, I think I told you this story earlier. There was a study done and they said people who eat lots of sugar get more heart attacks. Then there was another study that said that's not true. Okay? The lurking variable in that case was smoking. Okay? So what's interesting about that is the observed relationship can be used for prediction even if not the cause. Okay? Now, going back to my example I just gave you, even though sugar doesn't cause heart attacks, in that originally flawed study, I could still use the amount of sugar that people consumed to predict heart attacks, even though it didn't cause it. Okay? There was confounding going on there. So even if it's not the cause, you can still use that equation. Now, the better equation is to say, well, it's not sugar that's causing the heart attacks, it's the smoking. That would be the better way to do it. But I could still use that for prediction. Does that make sense? Okay. So, finally, we'll finish up on here and then we'll go upstairs and we'll take our quiz. So, the criteria to establish causation. Number 1, the association is strong. Okay? Smoking and cancer is a good one. 2, the association is consistent. Okay? Unlike the sugar study, it wasn't consistent. Okay? But the smoking is consistent. Okay? Number 3, higher doses are associated with stronger responses. Okay, the more you smoke, the shorter your life. Number 4, the cause predates the effects. Okay, you have to smoke for years before you get lung cancer. And number 5, the cause is plausible. Okay, you could do this study with animal experiments because that's more ethical than doing it on humans. Okay, so let's go upstairs. I've got the quiz from, so the quiz from Tuesday that I didn't do, and the quiz from today, so it's going to be on both of those. So we'll go upstairs, I'll answer a quick few questions, and then we'll, if I have time, we'll do their movie.